So welcome to all of you, and here we are going to discuss how you can analyze the splitting pattern in NMR spectroscopy. Okay, so first of all, it is the actually I have mentioned the del value of different organic fragments mighty. Okay, so you can see this, and I have explained in the before this lecture all the characteristics of this. Okay, so you can watch this video. Okay, so only in this I will discuss the splitting pattern. Okay, so suppose that if you are going to analyze this molecule and you want to analyze the splitting pattern of this molecule. Okay, so first of all, if you see here, this is the aromatic moiety. Okay, this is CH2 CH3 means ethyl moiety is attached, and this is OH. Okay, so this is tertiary OH, and if you see here one hydrogen. Okay, in this one hydrogen is attached, so near one hydrogen is present. Okay, so by applying the n+1 rule, this appears as a splitting pattern will appear as a doublet. Okay, and this for this proton, since near two protons is present, so that's why triplet will be present. Okay, and for this similarly, for this triplet will be present, and this one means two triplet and two doublet will be present. Okay, so two triplet means this one, in this one triplet and two doublet is present, and this one is containing one triplet. Okay, so according to this molecule, your spectra will be containing this splitting pattern. Okay, for OH only one splitting as a singlet will be present because only one hydrogen is present, and if you see for this hydrogen, splitting pattern will be for this quartet because near three hydrogen is present. By applying n+1 rule, it appears as a quartet. For this proton, it appears as a triplet, so one triplet and one quartet will be present here. Okay, so this one is the quartet and it will be the triplet. Okay, and where it will be appeared, so according to a del value, it will appear in a specific NMR spectra. Okay, so aromatic protons, you should be know that it appears 6.5 to 7 or 8.5 till. Okay, and quartz CH2 olefin means all the aliphatic protons will be appeared in the 1 to 2.5 region. Okay, so this region containing the aliphatic proton, while this part is containing the aromatic part. Okay, so similarly, if you see this is, so this aromatic moiety. Okay, so one hydrogen containing this, so only because near only there is no hydrogen, so this will appear as a singlet. Okay, so for this triplet, for this doublet. Okay, so one triplet and one triplet, one singlet and one doublet. Okay, appeared. So one triplet, one, not for that. If you see here in this one, this appeared as a one singlet. Okay, and one singlet, one doublet and one triplet will be appeared in aromatic region, while if you see is this one, so near two hydrogen is present, so for this proton triplet will be appeared, so one is triplet here, for this triplet will be appeared, so in this triplet one another triplet will be present. Okay, so these two hydrogen containing one hydrogen, so one hydrogen as a singlet will be appeared in the NMR spectra. Okay, similarly if you see this one, for this is CS3, this is CS2, so for this proton it appears as a quartet, so in this region quartet, if you see this is present quartet. Okay, and for this 2 3 2 5 means sextet will be appeared. Okay, so this is the sextet. Okay, and for this CH2 triplet will be present, so one triplet will present this one, and this hydrogen will appear as a this one. Okay, so this is the splitting pattern of this. Okay, similarly if you see this one, so for this proton only one hydrogen is present, so one doublet, for one doublet means two doublet will be appeared. Okay, so this is a, if you count this AB, so for AB if you see here, A and B will appear as a doublet. Okay, so two doublet is present here. Okay, for this doublet will be, and doublet will appear. For this proton triplet will be appeared, one hydrogen this one hydrogen this one. Okay, for this 2 and 3 means quartet will be appeared, so G it appeared as a quartet here. Okay, so according to this you can analyze this splitting pattern. Okay, for if you see this molecule, so for this triplet and for this proton quartet will be appeared, and for this proton triplet will be appeared, so one triplet and one quartet is present here. Similarly if you see here in this molecule, triplet for this, quartet for this. Okay, and this one appeared as singlet, so B appeared as singlet, while one triplet and one quartet will be present. Similarly if you see this one, aromatic moiety will be appear for 5 protons, okay, and it appeared actually multiplet. And for this quadret, for this triplet, okay, so 2 triplet, 1 quadret, and other triplet, okay, other for this triplet, okay. So it this splitting pattern will be appeared as for this 5 proton appeared in aromatic region, and it appeared as a this one appeared as singlet, this will appear as singlet, and for this appeared as singlet. See, so all splitting pattern will appear as singlet, okay. This COS containing, so one singlet will appear in acidic region, okay. So similarly, you can analyze this and also mentions the answer of these fragments, okay. So we will see this how you can learn from this lecture, okay. So thank you for all, and okay, so you can do exercise for that, and definitely you will learn this.